Okay, I can see Dennis joining us right now, right?
Yeah.
Can you talk for a while, Dennis? Or you kind of stuck in the meeting room or something? Probably you're unable to talk right now. It's okay. Let me prepare the thing first. Okay, let me prepare for the first tutorial. It's supposed to be on the 14th this month. Okay, but we kind of like because this time is very unusual. Student enroll in the last minute. Usually student enroll let's say 10 days prior to the actual tutorial. Okay, so this is the first one, the first tutorial we meet. Okay, let me make sure I start the recorder because sometimes I do forget to do that. Okay, somebody start. Okay, Dennis already started here. Right. All right, as you know, now it's all officially started. Let me double check again. Okay, so this is the WOU, electric circuit and power, semester 24A, and today is a tutorial 1. Okay. Your next tutorial is going to be not on the 27th. We already changed the date to 17 February.
February, yeah.
Yeah, 2024, right? Okay. Since the due dates for the let me put the timeline here. The due dates for the assignment number 2, which is your lab session, happen on I think on March 18 or 8. I forgot already. Let me double check. The second tutorial. The submission date, yeah, the submission date, that is the one that you should take notes. You know, don't overdo the submission date. Let me check. Yeah. So the 24 is quite. We have plenty of time actually from now until 24 March. So when we do it on the February 17, I think it gives you ample time to prepare for your assignment. Okay, for the lab report actually. So today is 20th 01. So what we're going to do today is focus on our CA1. Okay, so let's check the CA1 due date.
I think it's 11 February.
Okay, let me double confirm it.
Yeah.
The first assignment, as you know, the assignment is very important because you'll be assessed based on the assignment, not based on the your tutoring session. You're assessed based on the marks that you can get from your assignment. That's why you should always try to push, as high as possible to get the highest score as possible. So that's why I'm here actually to assist you to complete your assignment on the February 11, right? Okay.
Yeah.
February 11. So you have to take notes of these important dates. So let me kind of like talk a bit slower so that you won't miss out this important information. So we have this important day here. So let's look at the calendar right now. It's the 20th. So you have about 20 days. About 20 days to prepare. And I think you can do it, no problem. I don't think there's an issue to prepare the assignment. But before I begin, can I know a bit of background from you, Miss Tan?
Yes.
Is this your first semester with OpenU?
No.
It's not. Okay. That means you're already aware of how to submit the assignment. Everything.
Yeah.
Okay, okay,
Yeah.
good. How about Dennis? Are you able to talk? I think you
I
also, right?
think not. Yeah.
Because you are Dennis. Dennis is the graduate diploma also. I think looks like he is belong to the same category as you, Mr. That
Oh.
means he's already been with OpenU for a while, not for first semester. So I presume all of you knows how to submit your assignment and also access the Flex Learn. You're aware of this, right, Miss Tan?
Yeah.
You're aware
Yeah.
of this, right? Okay, this how you
Yeah.
this way you get your class notes or class material. Let me see whether it's there or not. Okay, let me look at the unit 1.
Okay.
Unit 1. So you have kind of like PDF file for you to download to your PC and read it.
Yeah.
Okay,
Yeah.
you can download. Actually, we have 5 units altogether. We have 5 units. But when we look at your time schedule here, 1, 2, 3, 4, 5. We have also a 5 tutorial session. But one is just solely for the lab. It's whole day, whole day. It's not this day anymore. Okay, please take note. It's on the 17th February.
Okay.
So that okay, let's back to the tutorial again. So we have 5 units. You need to read it yourself. As you know, this is a distance learning class. It's not a conventional classroom like a lecturer giving lecturing to you every class. This is the sort of like the tutorial class where I will give you some tutorial and you also to help you complete your assignment, your assessment. Okay, so that we assume that you will read through the notes by yourself or by yourself. I'm also your tutor only for these 2 hours. I'm not your tutor for the whole semester, you see. Because they open you, they pay me for these 2 hours only. They didn't pay me for the whole semester to assist you. So you by uh, logically that you should only ask question during this tutorial time. When the tutoring time is over, of course, you can ask some simple question. You can ask some simple questions like, is this to confirm something? Should you do this or should you not do this? But you cannot assume that I'll give you another tutorial time. Any time that you want it to. Let's say you don't understand this certain topic. You want me to do it with you. You want me to explain to you. Uh, because this is not how they work. You see, how it works is that. I'll be paid for these 2 hours to these 2.5 hours to provide you the tutorial, not the not the ad hoc kind of basis. Like you want a tutorial time, then you just request for tutorial. This is not how it works. Okay. So that okay. So what we're going to do in this 2.5 hour. Let me check the date again. Okay. So let me look at it because the timetable is very important. The second time we meet is going to be a February 3rd. Sorry, not this one. Sorry. The second time we meet going to be a 4th of February. So it's still before the first due date. Okay. So what it means is that from today until the next tutorial, which we can focus on our tutorial 1. Sorry, we can focus on our assignment 1. This is why I try to let you know. On this 4th of February, it's going to be your second tutorial. Okay, second tutorial. This T2, I got T2. And your due date is after that, after the February. Okay, so your third tutorial actually is a lab session. We now like push it back. It's supposed to be on this month. Okay, lab session. Since the due date is March, I think so. So everything looks okay. I don't see any issue. All right, let's after the I let you know the some basic information, and also I also let you know the uh, I also find out that you know how to submit your assignment. So
Yeah.
I think we can just go ahead and start the class right now. Okay. Let me see that your first assignment. Let me look at your first assignment. This I think it's about this. So be this one. Let me see. I think this one. So this one, this assignment, you actually you can download it from the FlexLearn. So
Yeah.
altogether, we have how many? We have five or four
Four,
questions. Four
four
questions.
questions.
Yeah, totally 100 marks. But this time, there's no cover. As quite strange, though. There's no cover for this assignment. Usually, they provide a cover. But
Cover.
I presume the assignment is the there's no other information. They just straight go to the question this time. Okay, there's no information or anything that telling you how many marks this assignment.
No.
No, I presume it's like usual 25 marks for assignment one, and then 25
Yeah.
marks for the next assignment, and then I think you do have a one final exam, which is an online test. You need to do it within 2 hours time.
Okay.
And so I think my purpose here is to beside to help you prepare your assignment, to also to make sure that you can able to answer the question in the final exam. I want to make sure that you can do that. This my purpose. So I try to fulfill this purpose. All right, let's look at the
Okay.
first assignment, shall we? Okay, first assignment.
Okay. Yeah.
Miss Tan, are you from the engineering background? Before that, do you have any technical background?
No, no.
You mean
But
you
I'm
come from the different
working
discipline?
on. Sorry?
I before that you came from different discipline. I mean different
No, no,
major.
no. No, no, no.
Do you know the all this like the voltage current thing? Do you know about all this?
I know a little bit because I'm working on electronical.
Uh-huh.
Yeah.
Uh-huh.
Right now, I'm working as a technician. So
Uh-huh.
I know a bit about this, but all this calculation, I'm not so familiar.
Uh-huh.
Mm.
That means this is the first technical class you enroll. Can I say that?
Yeah, yeah, yeah,
Yeah. Okay. Before that, you enroll just a normal general class, right? Like
yeah,
the
yeah,
mathematics, all these
yeah.
languages, right? Okay. All right. That means I need to pay more attention to all this. All right.
Okay.
Let's do this right now. Okay. So the first
Mm.
question is about the fundamentals of circuit. I mean the voltage and time function. So we call this a
Okay.
function of time.
Mm.
And second question is about the basic of circuit theory using the
Mm.
Ohm's law. Okay, Ohm's
Ah.
law, basic
Mm.
one, very basic.
Yeah.
The part C here is also very
Mm.
basic. Is related to the power, electric circuit
Mm.
power. Okay,
Mm.
how they works, how you should see them. And then when it
Mm.
comes to the question two, it's a bit
Mm.
difficult. I can say, if you read you can see the figure here. Yeah,
Mm.
sorry, I forgot to share my screen. Let me share my screen.
Mm.
Share my screen. On the question number two, you can see the circuit is a bit unusual. It has some funny symbol. Okay,
Ah.
so this is the current dependent. Wait, this is a current dependent current source. Okay, probably
Mm.
you never heard of this, but I think I will explain to you later on. So question
Okay.
number two is a bit you can say tricky. Okay, it's based on
Okay.
the Kirchhoff's current law or voltage law. Okay,
Mm.
so we probably will leave this one to the next tutorial.
Okay.
Then come to the part B. Part B looks at the fundamentals of the circuit theory.
Okay.
And so basically you just need to calculate the total resistance of this circuit network, the total resistance.
Okay.
We call the equivalent resistance sometimes. Okay, this considered easy. And this one is considered average. This one you need to know about mass analysis, because this question explicitly tells you to use the mass analysis. You cannot use any methods. You have to use the mass analysis to solve for the I1 and I2. That means you need to find the value of I1 and I2. Probably if you have time, you can do it today. If you do not have time, then we leave it to the next tutorial. And this one, I think this one should be the most difficult one, if I remember. Question number 3 is talking about the nodal analysis and the Thevenin theory. Both of these are considered tutorial 2 and 3 usually. If I remember correctly, these two belong to unit 2 and 3. Okay, they consider the
question 3 is based on unit 2 and 3, is it, sir?
I think not unit 1, unit 2 or 3. Okay. So we're not supposed to do this today, because to explain the how what is the nodal analysis and the Thevenin theorem, it takes a while, a lot of time to explain it. And question number 4 also. Question number 4, we have the Norton theorem. To use Norton theorem to solve for V out. This one is still quite okay, I think. This question is quite okay. This question is a bit tricky. Because you need to come up with a few equations. If you miss out any one equation, you won't be able to solve the unknown. The unknown is the Vx. You need to solve for Vx. And another Thevenin variable is the resistance, Thevenin resistance. You need to solve. It didn't tell you that, but when we say Thevenin equivalent circuit, we are talking about the Thevenin voltage and Thevenin resistance. We're talking about this. Okay. So back to the last question is a superposition theorem. There's another you can say is a small topic. Superposition sometimes is useful, sometimes you may not find useful. It's just a method, another alternative way to solve a circuit, to find the unknown in the circuit. Most of the time we can solve the circuit problem probably to analyze the circuit with just 1 or 2 methods or theorem or theory, like this mass analysis, nodal analysis, all this. So let's start from something simple. Okay. I think we can start from here, so no problem. We can start from here. Question 1.
Okay.
All right, let's start from question 1, shall we? All right. Let's see. So what you see here, first I want you to look at this diagram, this figure. So on this figure, you can, on the left-hand side, you can see one rectangular box. This usually means is the loop of the circuit or the whole circuit. Okay, there's a circuit here represented by these rectangular shape things. And then when we apply the voltage here, the things will draw some current. The current will flow through this unknown device, okay, unknown loop or something. So basically what we have, what's given us is the voltage and current. But the way how they present is a bit unusual, I should say, because usually the circuit will tell you how many volt you apply here. For example, for the car, we say 12 volt we apply here. But right now, what you're given is not a straight number, a straight integer, anything like. It's a 4 multiplied by the exponential to the -3t. So what it means, this one is the time dependent. Okay, so this value depends on the time. Depends on what time you want to measure. Let's say you want to measure at time 0. You put the t equal to 0, then you get some voltage here. So let's say you want to measure the time at 1 millisecond. You just put 1 millisecond here, then you will get a different voltage. That means the voltage is going to be changed with the time, just like this one. Okay, so this is an exponential function. That means initially when the time is 0, you'll get forward maximum. You can see that, right? When the time is 0 here, you will get the voltage of 4 here. Okay, it can be calculated when you place a 0 here. 4 to the e to the minus 0, you get 4. Okay, so this is ground 1. Right. So as the time progresses, you will see that this exponential value going to get larger and larger. Therefore, this 0 point something you become initially. I think initially is 1. After that, you'll get this term here, e to the minus of 3t. You'll get larger, smaller and smaller, and then when 4 multiplied by this term, the outcome, the voltage will be reducing, just like this one, exponential rate. Okay, so this is we call it the voltage as a function of time. The voltage as a function of time. Another one given is is even unusual. Is a current as a function of time equal to the minus of 2 times this voltage. But this voltage as a function of time now is presented in the we call it a derivative. This is called the derivative or differential. So this is like you need to do the derivative of this function. So what it means. Okay, so to prepare for your assignment, let me presume that this is the assignment. Okay. Q1 A. What you should do is you should clearly print out the question that you are trying to answer. So the part 1 is I find the current I through the device. Okay, let's do that. But usually you should type it in because I try to save time. I do use my pen here. You are not allowed to write. Actually, you have to type in the answer.
Yes.
Actually, I think this one they should revise for this policy. So this current as a function of time is a derivative voltage times -2. Okay, so this is not the final answer yet, as you know. This is not the final answer. If you provide the answer like this, probably you'll get a maximum of one marks only.
Okay.
1 marks out of the no, I don't think you're going to get 1 marks. 0.5 only probably. Okay, so even though you say find the current IT. So if you say this is a current IT, that means you are wrong, right? This partially you are correct. This is the current IT, but what you try to say is to find the value current IT through the device. So this one is already given. So basically you can argue this is the answer, right? But this is still not the final answer. We want to know the more how to say, the more closest to the actual answer. Closer to actual answer. This is not closer. This is still the really beginning. Okay, in order to do that, we need to do the differential. Can you see that? We need to do the derivative of this voltage.
Okay.
So what you can do is equal to -2. You take the d, and then you differential this term 4 to the e of 3t, and you differential this term, then you will get something more, more detail instead of this term. This term just a detail. Okay, now you have something here. You need to do the differential. Okay, let me show you how to do the differential. Okay, if you, because most of us already forgot the what we learned in secondary school. So but today's student is quite lucky. You can always use the online tools like this. So you go to this online tool called the Symbol Lab. Okay. Then you pick the let me see. So I use a function. Let's choose a function. Okay. Then you come here. Oh, this function is to plot the graph. Okay. Let's choose that one. Let's choose calculus. Let's choose the derivative. Okay, derivative. So you have example here how to do the derivative, right? Okay. For example, let's say you want to do the derivative of 2 to the e, and then you choose this one, e to the power of minus 2t. Okay, you can do the derivative like this, and then you click go, and then actually you'll show the result how to calculate this, how to do the derivative, this term. So the answer is here. This is the answer. So what I'm saying that your answer should look like this, something like this. Okay, I think I gave you enough tips already. So your answer should be something, something, exponential to the negative of something. Your answer should be like this.
Okay.
Okay, so this with this one all I can do right now. If I give you more, that means I'm helping to answer really. Okay, let's move on to the second question. Second question is 2. Let's do the second one. Second question, it says, find the charge delivered to the device. So this is a device here. Find the charge delivered to the device between the time 0 to 1. So when we see that there's something that asks us to do to calculate from this time to another time, most likely it's a kind of like integral. It's a integral, right? Yeah. It's an integral. From because integral help us to calculate the average value from one time to another time. Okay, for like this example. So you should use something like this, the integral. The integral from the initial time, we put 0 here. So let me see. Okay, we put the 0 here. And to 1. Okay, simple, 0 to 1 only. So we need to do the integral of this this equation.
Okay.
This term. So how do we know the total charge? How do we know the total charge? What is total charge actually? So let's back to a bit of physics. Let's back to a bit of physics. On the physics, do it elsewhere here. Let me do it elsewhere. Okay. Let me try to explain to you. From the physics point of view, a current is flow of charges. Okay. Let's say this is a wire. This is a wire. Then we have assumed there will be a lot of charges flowing through, positive or negative charges, proton or electron, flowing through the wire. Okay. So how do we measure the total electron flow through the wire? Actually, the one method we use is using the measure of total electron flow through it. So at this point, let's say the point A, we measure how many electrons flow through this point A in 1 second. How many electrons flow through the point A per second? The charge per second. Actually, charge we use a Q most of the time. We use the symbol Q. total charge flow through point A per second actually is defined as current. You see, to measure the total charge flow through certain point in the time, find the total charge flow to the device, total current. Total it's not saying the total. Wait a minute. Oh yeah, I'm looking at the part 1 again. So let's look at the part 2. Find the total charge delivered to the device between 0 to 1. That means also can be said that is a total charge flow through the device between 0 and 1. So if you understand what I'm talking here, the current actually is a measure of total charge flow through certain point per second. So you can also try to look for the let's try this AI. Let's define current. Let's say whether the AI mentioned about the total charge or not. Okay, let's see whether does it give us any good information. I think today when you learn something, you should always take AI as your co-pilot, to help you understand more about certain theory. This how you should do as a student in 2024. You should always let your AI be your co-pilot, and help you to understand, to review whatever you need to know. So the current, the direct current, then you say the current is the electrical charge flow in one direction, and then okay, so you can. I think it's not really detailed yet. Probably I should rephrase my question. What is current and charge? Okay, let's see whether it gives us a good answer. It's quite slow, Julie. Meanwhile, let's come back to here again. It's not moving. Never mind. I think it's stuck somewhere. It come out already. Okay. Yeah, I think I see something very important here. It said that the electric charge is a fundamental property. Okay, we have two types of charges. We have positive and negative, proton and electron. So to measure the charge, the unit of charge is one coulomb, measured by coulomb, the unit of charge. The current ampere is defined of how many charge flow through in 1 second. Per second, you see. The current is equivalent to 1 coulomb of charge flow per second, 1 coulomb. Okay, let's write down. The current I actually is defined as 1 ampere. Sorry. The current is ampere. Is defined as charge of 1 coulomb per second. 1 coulomb per second. One charge carry very small amount of coulomb only. One charge only carry 1.6 to the 10 of minus 19 coulombs only. So 1 coulomb is a very huge number actually. Don't be fooled by this one. This one is really really large number, because one charge is only 10 to the minus 19. Okay. But this is just a background only. Let's go back to the question. So the question say find the charge delivered to the device between 0 and 1. So what it means is that it wants you to use the integration. What it wants you to do is total charge, right? Total charge. Okay, let's do this. Total charge. He wants you to find the total charge QT. Let's say the Q is the total charge, equal to how many coulomb Column. We seldom use this word, columns. How many columns?
Oh, okay.
Okay, he wants you to find how many columns, not ampere.
Okay, column.
How do I know it's not ampere? Current is measured in ampere, but charge is not measured in ampere. Charge is measured in coulomb. You see here?
Okay.
Charge is coulomb. Okay?
Column.
Yeah, coulomb, right? Coulomb. Coulomb. Okay? Coulomb. Then he wants you to measure the total charge. So the equation what we can use, I can tell you that straight away is a 0 to 1. 0 to 1 second. The current is equivalent to 1 coulomb per charge flowing per second. 1 coulomb, okay? But charge only carry this small amount of coulomb only. So what he wants to do is, we can use the integration from 0 to 1, and then we can use the current as the current functions, because the current measures the total amount of charge flowing through the device. Okay, if you read again here, current actually is a measurement of total charge flowing through certain device at 1 coulomb per second. So the current function here will give us we can use the current function here to measure the total charge flow through the device. Okay, just like that. You put the current here from 0 to 1, and then we do the integration. This should give us the answer in coulomb, not ampere. Okay, don't be fooled by this current. Look at current, you must most people think that the answer is ampere. Is not. It's a coulomb.
Column.
Because this match the question also. Question say measure the charge, not measure the current, measure the charge. So current and the charge, they have this relationship. Let me ask one more question. Okay, so let's come back to here again. So from the previous part, you already find the IT. So you use this answer here. You use the answer from your part 1. You insert into this equation, and then you do the integration. You will get your answer. Okay. So what you do is like this. You put the answer from part 1, something that exponential 2 minus something. Okay. Then you do the integration. You will get the answer in column. Okay, so one I think I a bit confused here. 2 dash, right? Let me use better symbols. Let me use a better one. Let me erase this one. I don't want to confuse the student. Okay, let me take away this. That means you need to find out the unknown here and the unknown here. Then it becomes 0 already. This becomes 0. So this like this, okay, like this.
Okay.
So you need to take something here, calculate yourself something here, and then you'll get answer. They're not really a circuit theory. All these are physics. I presume that you can do that. Okay, let's come to the last question. Calculate the power absorbed by the device. Okay. Basically, what we have known so far that the power, most engineering students understand power actually is a product of voltage and current. Voltage and current. That means if you have you know the fixed value of voltage, fixed value of current, you just multiply this together, you will get the power. We call the instantaneous power. That means the power consumed at that moment. Okay. But most of the time, the voltage and current, they are changing with time. They are not fixed. They are changing with time. And that's why we need to use the different methods. So in this case, the voltage and current, they are not fixed. You can tell by looking at this graph here. The voltage is not fixed, it's changing with time. Current also, I presume this is the fixed resistance. Current also change with the time. So they are not constant value. When they are not constant value, we cannot just multiply the voltage by current like that. Okay. In this case, we need to write use a better terms. Is power as a function of time. That means this power will change the time. Okay, it's not constant. It's a Vt time IT. Vt and IT, you know Vt IT already. This Vt and IT is the one you just found from part 1. So you just multiply them together, and you will get the answer in the unit watts. Watts. This answer. So do you have any issue with this for this question?
No.
You quite confident you can do this, right?
Yeah.
Can you are you doing it right now, or you just watching the screen? Are you trying to do it yourself right now?
Yeah.
Probably you can share with me your answer. Let me give some hints. Is correct or not? Do you have an answer already? If you have,
no,
I
don't.
can confirm with you whether your answer is correct or not. Never mind. If you are not confident to do it right now, then we continue to talk about the next question.
Yeah. You can continue.
Okay. So the next question, I think I should let me see. I think we can do this also. Okay. But I prefer to do this one first, actually. I prefer to do this. All right. Let's do the let's skip some question there. Let's jump straight to the question 2B.
Question.
Okay, 2B, because we can jump around here. Let's do Q2B. Q2B. This is the next. This is not easiest one. Sorry, this is not easiest one. The next easiest one is here. T1. Let me. T1 trust. All right, Q1B. Okay, Q1B. I can give you the tutorial. Hold on, let me give you one tutorial. I give you the tutorial so that you do it, and then you learn from the tutorial. Okay. Let me find the one. T1 here. Yeah, this one. Yeah. Let me copy this. Okay, Miss Tan, I want you to try this question. Even though it's not exactly the same, but after you know how to solve this, I think you have confidence to solve this question. They are quite similar, right? They are not similar, but they belong to the same question. That means you give a bunch of resistance here. They are interconnected resistance. You need to find the resistance here, the total resistance, looking into terminal AB. So if you try to measure, what it means is if you get a meter, you try to measure terminal A and B of the total resistance in the circuit here. Just like this one. To measure the REQ. REQ is the equivalent resistance of the total here. Okay. So let me give you some background information. If the resistance is in series, that means they are connected in one line. You can tell by counting the number of nodes. You see, one resistor they have two terminal, right? One resistor here, 1 and 2. The resistor here also have 1 and 2. But when you join these two resistors together, they only form three nodes only. 1, 2, 3. Because the center one they share. We call the common node. This is common. So two resistance, we get three nodes. That means they are in series. You get the point? Okay. Because one resistance has two nodes. This is called the nodes.
Okay.
One resistance has two nodes. Two resistance to have four nodes, right? But two resistance we have three nodes. 1, 2, 3. When they join together to form a three nodes circuit. So this is called a series. Another way of configuration you can do is you put them like this, and then you join them like this, point to point. Then they only have two nodes only. They only have two common nodes. We call it common. When you join this node and this node together, they are similar, right? It's called common.
Yeah.
So yeah, but when you do this, you reduce the node to two nodes only. That means two components, two nodes. That means this configuration is called a parallel. Can you see the difference?
Yeah.
So parallel, you need to use this formula. The RT1, record the reciprocal value. The reciprocal value 1 over RT is equal to 1 over R1 plus 1 over R2. Or the simple way is you take the product of R1 and R2, you divide it by R1 plus R2. Okay, you can do that.
Yeah.
So if you understand, can you try to do this later? Probably you can tell me your answer.
Okay.
You do this, okay? Mr. You do this later. I give you 5 minutes.
Okay.
5 minutes. I'll confirm with you whether your answer is correct or not. Okay, let's do this. All right. Miss Tan, are you there?
Yeah.
Have you done? Have you find out the answer yet?
Is it 3 or 4?
So what's your answer for this circuit?
3 over 4 ohm.
3 or 4?
Is it?
How come we have all? Do you have a fixed answer? You mean the answer is between 3 to 4?
No, it's 3 over 4.
Oh, 3 over 4. Okay, sorry. I thought you said 3 or 4. 3 over 4. Huh? Okay, let's find out whether you're correct or not.
Okay.
First, we look at the 6 and 3 because they look like parallel to us because they have 2 resistors and only 2 common nodes. So we use the parallel formula. On the top is product and at the bottom is a sum. So we get 2 ohm here, 2 ohm to replace these two. And then on the right hand side here, we have 1 and 5. So they are quite clear. They are in series. Unlike this one, they are in series. Therefore, we can just add them up to form a 6. And then now we have 2 and 2 here. 2 and 2, we can just add them up because they're in one string, one line. So we just add them up to form the 4. And this is what we have after we done some step. And then what we should look at is now to parallel these two, 4 and 6. When we parallel these two, we get 2.4. And then at the end, we have these 3 connected in one string. That's why they are in series. So we just sum these 3, we get the total of 14.4. Is it a surprise to you? So what I want to know whether you can you solve this one or not?
Yeah.
I don't know. If you need more example, you can go online to find more example. You can go online here. You can say calculate equivalent resistance. You'll get some example or something. This one example here. One example. Another example is here. But this one is with the voltage. Okay, we do want to find those with the voltage. This is another example. How to find the equivalent resistance? Yeah. Another example is here. There are many. Okay, there are many. So because just now you couldn't provide the correct answer, so I still cannot say 100% that you can solve this one. Okay, but you need some practice. Okay, don't be despair. You need some practice. All of us need practice. No one will become expert in one day. Okay, all of us need a practice. So if you're not so sure, what I suggest to you is that to look for more examples online. Probably you can ask AI to give you some example. Let me ask AI whether it can do that or not. I don't think AI can plot the circuit. Give me an example of calculating whether AI can. I don't think nowadays AI still cannot plot any circuit. Probably just use the words to describe, I think. So let's find out what it can do. It's quite a slow rounding. Okay, meanwhile, I think we can look at the next question. Beside this question is your second attempt. I would suggest the next one we look at is this one. Because it looks rather simple. It is the something related to the power of the circuit, to the power. Okay. So let me dig out some example from the past, whether I can find some example that can help you. Hold on here. Let me dig out some example. Looks like not easy. Probably I need to do it. Give you the example right away. Let me try to look for a few more seconds. Then I'll let you know. All right. So you have this circuit here. What I can see here, we see 20, 27, 12, 25, 15. They are the voltages and 3 voltages and 1 current given for the whole circuit here. All right. So let's read the question first. Identify which elements. So this element B, element A, and identify which element are supplying power, which dissipating the power. So he said that which one is actually supplying the power, which one is actually dissipating the power. Okay, this is part 1. Part 2 is said that to calculate, to determine the power dissipate or supply for each element here. So we have 3 elements. We want to calculate the power for these 3 elements. Okay. All right, let me give you some background information before we try any attempt. So first of all, voltage measure for this component. Okay, let's say we have this component here. Let's say in the beginning, you know that this is the voltage. It's a power supply. Let's say the 10 volt power supply. And then let's say you have one element here. It's called a resistor. Another one is here. So you connected them in this way. You join them together to the power supply. So we have R1 and R2. Okay, let's give it some value. Let's say this is the 7 ohm. This is 3 ohm. The way how I pick the value is to match the 10 actually. So they are divided equally. So this is the element we know, and this is the element that we know of. We also know the value, exact value. So what happens is let's start to analyze this circuit. Okay, let's start to analyze. So when you analyze the circuit, first you look at this terminal. We start from the left hand side. Okay. So this negative value here, if you going around, when you're going along this path, you look up, you see the negative value first, right? Not the positive.
Yeah.
What you see in front of you is negative. So we use the KVL first. KVL, the Kirchhoff voltage law. Minus 10. This minus 10 because we see the negative first. Okay. And then when we go past this one, when we come to this junction, we need to give some value here. Okay, let's put the positive here and negative here. So so this one is not called the resistance, it's called the voltage. Voltage R1. Okay. So when the first thing you see here is a positive. So plus PR1. Then you come around, when you see this R2, you also see the positive first. But the positive value is what we given to this element right now. Okay, based on experience, usually the positive is here. So plus VR2. VR2 is the voltage across this resistor. So based on the KVL, the total should be 0. Okay, that means because in this circuit there's only one element supplying the power, the other one is the consuming the power. They just take the power. This one is supply. This one is the receiving the power. Another way you can describe this circuit is like this: V1 plus V2 is actually equal to the total power. So if you understand how this equation try to tell you, it tells you that the one supplying the power should have the negative value, as opposed to the one consuming the power. The one consuming the power, you have the opposite sign. You see that or not?
Yes.
The one consuming the power has the opposite sign compared to the one supplying the power. Because when you arrange on the equation like this, you can tell they are on the each side. This one on the left hand side, this one on the right hand side. From here, you can tell that this is the one supplying the power. This is the one because right now we know everything already. Right now we know that which one is supplying power, which one is receiving the power. Okay, then let's go ahead and calculate this value to finish off. Okay, so actually this value, to add these two together, is 10 ohm. So based on the Ohm's law, the current flow through the circuit, because there's only one current flow through the circuit, only one current. If this current flows in a loop, only one loop here. So for this, we can use the fundamental equation, VIR. Current is equal to voltage divided by the resistance. Okay, so let's take this value. Current is equal to voltage divided by total resistance. Okay, so the total resistance we know is the 10 volt here. There's only one voltage here, and then we have the total resistance here is 10 ohm. So the current here comes to 1 ampere.
1 ampere.
Yeah, right, 1 ampere, right? Okay. So let's go to the VR1. Therefore, VR1 is equal to voltage equal to current times resistance, right? Is 1 ampere times 7 ohm. So it becomes 7 volt. All right. So let's calculate that one. VR2 is equal to still the 1 ampere here, because 1 ampere flow through the two components times 3 ohm. So it becomes 3. So what you can see here, 7 volt and 3 volt, they make up the total power supply. Another word is to say is that these two components, they share the 10 volt. They kind of share among themselves. The 7 ohm one share more voltages. The 3 ohms share less. This is what we can observe, right? We can observe that more resistance share more voltages. More volt. Yeah, more volt, right? But when you sum of their voltages, when you sum of these two voltages, they should come to the maximum of 10. Can you get the picture? Can you get the picture from here?
Yeah.
You understand, right?
Yeah.
Okay, let's do it the other way around. Huh? Let's do it the other way around. Right now, you try to hide this one from the user. Okay, you try to hide this one. Let's try to hide it. Okay, try to hide it. We just draw a box. We call this box A. And then we review this polarity to the user. Positive is here, negative is here. Okay, we review this polarity to them, and then we also let them know the voltages also, 10 volt. But we hide this component. Okay, we hide this one. We name it element A, just like this circuit, element A. Yeah. Then we do the same for the rest. For this one, we hide it. We don't want to know what it is actually. Is this a power supply or is this just a resistor to consume the power? We don't want to let them know. We hide it, but we need to provide the polarity. And then we say this one is 7 volt. We need to let them know the value. Because we cannot hide everything, right? We need to let them know something so that they can guess. So the last one is C. We let them know the positive is here, the negative is here, and then it's 3 volt. Now can you see better picture? What is going on? Can you see a better picture now?
Yeah.
Can you tell me what you see here? Can you tell me what you see here? What you
we
miss?
got all the voltage, but we don't know the element. What is the element there?
Yeah.
So now we need to find out the resistance.
No. What if somebody draw this circuit in front of you? What would you think? What's the first thing come to your mind if somebody show you this? Yeah, but you can try. There's no penalty. Any penalty. You can try whatever you want. Whatever in your mind, you just let me know. Okay, never mind. Looks like you're still not confident enough. Let me tell you what I think about this. Okay.
Okay.
When somebody show me something like this, the first thing in my mind it tells me is that I have three unknown elements. I'm not sure whether this is a power supply or this is a resistance. Okay, this is the first thing I know. I'm not sure what is their true color, whether this is the power supply or this is a resistance. So they just named as A, B, C. And then I'm given the 3 voltages here. Immediately I can see that 10 kind of like distribute to these two, because I can tell that 7 plus 3 equal to 10. Looks like 10 is the one to supply.
Okay.
How do I know? How do I know 10 is the one to supply? Cannot be 7, right? How can 7 supply 10 and 3? Must be 10 supply 7 and 3, right? Let's say you have 10 ringgit here. You give 7 ringgit to friend B, 7 ringgit to friend C. One more time. If you have 10 ringgit with you, you're giving away 7 ringgit to friend B, 3 ringgit to friend C. This is what I think, right? I want to double confirm whether my theory is correct, but whether my assumption is correct. I can make the following assumption. First, I look at the sign. Because look at the sign, if I go around this loop, the first one I see is the negative. When I go around here, I see the one is positive, and then when I go around, I see the one is positive. So one negative, two positive, one negative, two positive. This negative is 10. The other one is a 3 plus 7. That means this must be supply. It's supplied to this. So I'm guessing this one must be power supply. This one is a resistor. And this is how I assume that make the assumption. Also pay attention to the polarity. Pay attention to the polarity. It's really important. What positive is here? Positive is here. Pay attention to the orientation of this polarity. Okay, this is the actual circuit. This is the actual circuit. This is the partial review circuit. He only review to you the voltages and how they connect. They didn't show you the detail whether this is the power supply or this is what, right? Right. When you back to the this circuit again, did this look clear to you now? Which one is supplying power? Which one is dissipating power? Which one is dissipating the power? Dissipating power means consume the power. Supply means the power supply. So which one supply, which one consume? I think you can guess, right?
Yeah.
Part A, identify. Identify means you point out which one supply, which one is dissipating. Am I clear enough on this?
Yeah.
Right.
Okay.
Just look at this one and take this as an example. They are 90% similarity. They are actually 90% no, similar. And are you confident enough now to answer this question?
Yeah.
1C. This is a 1C. Is what? 2B is, yeah. Let me. Okay, because I cannot give you the answer here. What I can do most is to assist you. This is a 1A. Okay, let's put the 1B here. 1C is here. Oh, yeah. Okay, so this your answers will looks like. Okay. Let me tell you how to answer this question. I use the character element A equal to what? Supplying or dissipating power. Choose one. Okay. Same for element B and C. Please don't answer, right? I hope I'm not confusing you. I just give you the how to answer this question. This part 1. So part 2, you need to determine the power. Part 2. Part 2, use the P equal to V is equal to how many watts? Okay, from here it gives you the current already. Of course, you can multiply. Okay. But be careful. Be Be careful.
Mm.
Let me put the notes here. Notes. One thing, only one supply, I can tell you one supply.
Okay.
One supplying the power.
Mm.
Okay, have negative value. You get what I mean or not? The one supplying the power has a negative value.
Okay.
Example, for example,
Mm.
for example, minus 100 watt equal to 70 watts plus 70 watts. That's what I mean positive. Okay. Minus, because all of them add up become 0. Like this, like this. So put it like this. Because based on the fundamental law of physics, the conservation of energy, the one supplying equal to the ones receiving. There's no more than 100%. You are eventually you'll get 0. The supply minus the take away should get to 0. So from here you can tell this one is supplying power because this one supply to these two. These two add up become 100 watt. And the one supply should have a negative value. The one consumed has a positive value. Some students they argue that the one supply should have positive, the one take away should have a negative value. Logically, it looks like this. The one supplying the power should have the, but when it comes to the circuit, when you think of the dissipation of power should have a positive value. Supply should have a opposite symbol, which is the negative. Okay. So this is the 2C, 1C, 1C. Okay. All right. How about we take a break here? It's already half the session.
Okay.
We take a break here for a while, about 10 minutes.
Yeah.
Okay. All right, I'm back now. Are you around? Okay, probably I should wait another few more minutes. Hello, Mr. Are you around? Are you back
Yes,
already? Okay, let's
yeah,
continue.
yeah.
Okay, now we have another 15 minutes to go. Okay, let's look at the next question. So I presume you know how to solve this question. 1C.
Mm.
Let's look at 1B right now. Okay, 1B.
Mm.
1B Q1B. Right. Part 1. Refer to figure 2. Okay. So but part 1 actually nothing to do with figure 2. Part 1 asks you to explain what is the Ohm's law.
Mm.
So to me that this is the given marks actually.
Mm.
Because you can always ask AI to explain to you, right? What is the Ohm's law?
Mm. Mm.
You see, let me ask
Oh.
AI. But I don't encourage you to just copy and paste on it, right? I want you to actually read
Mm.
the content, okay? Even though AI can help
Oh.
you help you a lot, But if you too rely on the AI, probably it's not good for you actually. If people ask you Ohm's law, you cannot explain in front. You just need to refer to AI. That means you're not the you're not equipped yourself with this information. So it's better for you to learn how to explain it yourself. So you only use AI to assist you. Ohm's law is this one actually. V equal to IR, or another form is I equal to V over R equal to V over I. So like what I use is like this: VIR, I equal to V over R. V on top, IR on the bottom, IR at the bottom. So I equal to V over R equal to V over I, V equal to IR, like this. And the Ohm's law, actually Ohm's law tells you the these three properties. We call them properties: current, resistance, and the voltages. They are actually some kind of property in the circuit. So these three properties, they have a relationship. The relationship between I and R can equal to V. Okay, this is how we see this. This is how they can be how they relate to each other. Let's say you have V and R. You want to find the current, then you can use this formula. Okay, and you can say another point is that it's actually proportional to each other. They are directly proportional to each other. That means V equal to this one, they are proportional to each other. Okay, and there are about some of their application. So you can try to answer this question, 5 marks question.
Okay.
You can use together the use words and figure to help you explain. Words, figure.
Okay.
Preferably you use 3. Well, what I would suggest is that on your answer sheet, first you describe what is the Ohm's law in words. Okay, in words. Ohm's law. Okay, and then explain it. Okay, and then you giving the equation, for example. Okay, and then if you can, you give the example. Okay, example I equal to R equal to, then you calculate. Okay, you give an example to help people understand it. So if you want to get a full, you have to do this. I equal to X, R equal to Y, and what is value of V? This is how we apply the Ohm's law. Okay, how we apply the Ohm's law. But, I think it's clear enough. Let's move on to the next question.
Okay.
Next question is a bit tricky, of course. It said that by using Ohm's law, refer to figure 2, find the currents I1. All right. So we only allowed to use the Ohm's law. Okay, no, and nothing else. Use Ohm's law. So this is the Ohm's law. Yeah. Yeah. Wait, no. Ohm's law is here. Okay, we are using Ohm's law. Find the current I1. Can you immediately tell the value I1 already straight away? Can you tell the value of I1 straight away? Part 2. Find the current I1. So if you understand Ohm's law, I think it's able to tell I1 right now without any analysis. Without any further analysis, I think you can tell the answer right away. You think you can do that?
Oh, no.
Yeah, okay. All right. So let me give you a hint. Let me give you a hint.
Mm.
Let's back to this question again. Okay. Back to this question again.
Mm.
We already been using this one for a while. Okay, let me move this one slowly further out here. Okay. Let's use this as example. Just now we already determined the current is equal to 1 ampere.
Mm.
We are quite sure that 1 ampere flow through the circuit. Only one current, only one loop. This is called the loop, 1 ampere.
Mm.
In other words, is that this 1 ampere coming from power supply, it flows through the part B, also the C, or here. Let's put it here. This 1 ampere flow through the 7 ohm and 3 ohm.
Mm.
Okay. So if somebody already calculate the voltage here, let's say your friend, your colleague, let's say he tell you that VR1 is equal to 10 as equal to 7 watt. He measure it, okay? Your friend measure it, this point and this point, this node and this node. And then he tells you the voltage is 7 volts. So he wants you to find the current flow through it. Okay. Now it's your job to find out the current flow through the 7 ohm. Your friend tells you this 7 ohm, when he measure it, is 7 volt. So the friend asks you, what is the current flow through the R1? So your formula is like this: I equal to V over R. 7 volt over 7 ohm. This is the answer. Am I clear?
Clear.
Okay, you back to this question again. Do you see anything?
Yes. 16. Okay.
So
One
this is a hint for part 2.
Mm.
Note, sometimes look at the notes. Probably I should help you further, because you need more help, I think. Now we don't want to look at this 3 ohm and 10 ohm, okay? We don't want to look at 3 ohm and 10 volt. We just focus on this 7 ohm. Is enough already. 7 ohm, right? So if somebody measure the voltage here, he take a voltage meter, wattmeter, he measure this node and this node. Okay, you pay attention to my my words. This node and this node actually is a voltage across. We call it voltage across. Voltage across 7 ohm. Some will say voltage drop across 7 ohm. Is 7 volt here. So the current flow through this one can use this formula. 7 volt divided by 7 ohm. Now you clear? You look at this again. Do you see anything? If you compare this to this, you compare this circuit, compare this circuit, are they the same actually? I think they're the same actually. Only the number changing only. So you have to be flexible a bit. So what I mean is that let me save this one first also. Let me save this one.
Oh.
Hold on here. Slide 1. All right. So you have to be a bit flexible when you look at the circuit. So if somebody draw you a circuit like this, it said that it's a 7 volt plus minus R1 VR1. Actually, what you can think of is the measuring from this node to this node. The voltage drop across these two nodes. Okay, the voltage drop across these two nodes. Even though they have this circuit can continue to connect to other components, but sometimes the circuit may appear like this. VR1 plus minus. It's still the same thing, right? It's still the same. Sometimes it appear like this. Like this. It's still the same thing. So the orientation is not important. The rotation is not important. The important thing is that the voltage across these two is 7 volt. So 7 volt measure from here to here. That means across the component. Okay. 7 volt across here. And if I give you, for example, for this circuit, for this component alone, for this unknown component, if I give you the current flow through it is 1 ampere, and then I tell you that the voltage here is 7 volt from here to here, 7 volt. So I'll ask you what is the resistance. R equal to VIR, R equal to V over I, equal to 7 volt over 1 ampere, equal to 7 ohm. For this. And then here, if I give you the ohm here, let's say I give you the okay, let me give you a different one. Let's say I let you know that the current is 1 ampere. The ohm is 7 ohm. What is the voltage? What is the voltage? You look at these two nodes from here to here. 1 ampere flow through 7 ohm. So we can apply the Ohm's law. V equal to IR. 1 ampere times 7 ohm. Am I clear? I think I already make it too clear already. Probably you're confused also. Sometimes when we make it too clear to one person, right? You're very confused. The basic thing is really simple. If you look at this, okay. I think I cannot spend too much time here. Let's proceed to the next one. Let's proceed to the part 3. Part B is what? To find the current I1. I1 equal to something. Okay. This is a part 2. Let's move this one here. Right, now let's do part 3. Part 3. Using the voltage division rule and find the voltage V out. VO actually refer to V out, not V0, V out. I think this is a small mistake. Okay, let me tell you what is the voltage division. Let me give you some example. 2. Okay, voltage division. For example, we have 10 volt here.
Oh.
Just think of the voltage as the water pressure. You have a tanki here. You have the water reservoir inside of water, right? Okay, so this is water. Actually, water you can assume is the current, the charge. Water is a charge. Q. Okay, and then when you raise this reservoir up, okay, above ground level, this is ground. You raise it above the ground level. I'll now explain some physics to you. This is a ground level. The distance here between the ground level actually is called the voltage. For the water, it's called the pressure. Pressure is equal to voltage actually. The voltage. Okay. When you put it on the ground, same level as the ground, the potential is 0. Okay, the water cannot flow. But when you raise this up to certain height, you actually give some pressure to the water. Now the water here, a bunch of charge, consider as a circuit. There's a bunch of charges here. It's already got some potential energy. So voltage and pressure is some kind of potential energy. It's just hidden there. You can't see it. You can't feel it. It's there already. The pressure is there. So all you need to do is you now make a hole here, and then you're connecting a pipe. You make a hole, you're connecting a pipe. Okay, a pipe here. And then you open a valve here, you release the water. The water coming out here is actually flow of charge. The charge flow out. Okay? So the amount of charge flow out per second, if you put another container here to receive the water, the total amount of water flow out we call the flow rate. Flow rate is defined as how many liter per second or per minute or per hour. How many liter can flow out per minute? This actually is a current. It's a current or circuit current. How many water can flow out? It's a current. How high is the tanki? Is the pressure? Is voltage. So another missing part is the resistance. So if you put if your tanki is already clogged up, it's already have a lot of dirty dirt built up here inside tanki. This is some kind of resistance. So the water flow rate will be reduced because there's some resistance here because of this clog. Okay, this is a clog here. Because of the clogs here, the water flow rate reduced. This is resistance. Okay, of course you can put a valve here to control the flow rate. So your valve also some resistance. So the water flow out is a bit less. This is resistance. So when you come to the circuit, the voltage here is the potential energy, the pressure. The first resistance you connect to this resistance, the water flow down. The first resistance is 7 volt, for example. Sorry, the first resistance is let's say the 7 ohm. The next resistance, let's say, is a 3 ohm. And then this is a ground level. Actually, this is also called ground. When the 10 ohm here, if you measure the potential here, the potential here is 10 volt. As you measure the potential here, the pressure, water pressure. When you go past the 7 ohm, because this is some sort of a resistance, the energy here will drop. You no longer 10 volt here. It will drop by the ratio. We call the division, the ratio. So the ratio here, based on the amount, 7 plus 3 equal to 10, it will drop 7 volt. So at this node, it measures as 3 volt only. And then after the 3 volt, at this node is measured as 0 volt. So what it means is 7 volt drop across this 7 ohm. 7 volt drop. This is called a voltage drop across this 7 ohm. Another voltage is here, 3 volt. 3 volt drop across the 3 ohm. So the voltage division rule say that 10 volt being shared by these two resistance, 7 plus 3 equally, they share equally. Okay. So there's a formula actually. Let's say this is the R1 and R2. VR1 here. Actually, you can use the ratio. VR1 is 7 ohm plus the total. 7 ohm plus 3 ohm. 7 ohm share this 10 volt. So share 7 volt. Okay. VR2 based on the voltage division. 3 ohm based on the total 7 plus 3. Share the 10 volt, total of 10 volt. So 3 ohm get a share of 3 volt only. So this is the meaning of voltage division. They divide the 10 into 2 parts, 7 and 3, based on the ratio. Okay. So if you understand this one, then you come back to this question again. This output, actually 6 volt here, we have negative 6 volt here. Is shared by this one and this one. Can you see that? Because here's a ground level. You should ignore this one first. 6 volt, the potential here. Let me copy this one out first. Okay. Okay, so this, if you look closely, negative here. So this here is negative 6 volt. Right. So by right, we should consider this one as the ground. By right, we should consider this one as a ground. By right, okay? Because here is a positive, and this branch is a negative. Okay. But actually, when it comes to the circuit, we can always assume the positive here. That means you take the meter, you take the measurement, you put the positive here, you put the negative here. So what do you measure? You get what I mean now? Now the confusing part is the polarity. We have a positive here, negative here, and then we have positive here, negative there. They are just upside down. This doesn't matter actually. This doesn't matter. What I mean is like this. What I mean is like this. If the current, there's one resistance here, assume it's a 7 volt again, 7 ohm resistance. If the current is flow from here to here, from the right to the left, okay, in this direction, usually we will assume the positive is here. Usually, okay. Usually we assume the positive here because flow from here to here, from here to there. So we assume the positive here. So if you measure the voltage here, if you say V VR1, let's say VR1. Sorry, there's no VR1 here. V7 ohm. let's say you put a V7 ohm here, positive and negative here. Okay, and then your measurement comes to 7 volt, positive 7 volt. Okay. Another guy take the meter, watt meter. If the guy put the positive here and negative here, opposite, he take a voltmeter to measure this one, and then the answer is negative 7 volt. It depends on how you measure it. If you measure the correct way, you get positive. If you measure the different way, you get 7 volt. So what does it mean also? What another word is, if you measure is a negative 7 volt, that means what your measurement is opposite. The positive should be here. This reading tells you the positive should be at the other side, not here. You get it opposite. It's already reversed. So the sign here is only indicate the direction only. You don't need to worry too much. It only indicate the direction. For example, another example. Okay, let me give another example. Because this is quite important, even though it's really basic. You see the current I is flowing down, right? Current I1 is flowing from the top to the bottom. This is what we assume. Okay, this is what we assume. But if your answer, if your answer I equal to, for example, negative 2 ampere, you calculate it to be negative 2 ampere. What it means is the current should be flowing up. This is what it means. This polarity only indicates the direction of the current flow. And this polarity of the voltage only indicate the measurement at this point. When you measure the positive here, negative here, what is the answer? But I can tell you that the actual answer here is negative something. Okay, it's negative voltage because at this node is negative voltage. Then this voltage shared by, if you think it's shared by this one, you need to look at my previous example. This is the highest point. The next point is here, and then next point here. Then you go back like this. You see, you look carefully. I'm starting from here. I go to here. This is the first point. There's one voltage here. When I come across here, the voltage will drop. Imagine just now my previous example. This is the initial point. After this point, voltage will drop. Is here. And then voltage, when you cross here, voltage will drop some more. One voltage will drop here, another voltage will drop here. One voltage drop, two voltage drop, then you back to the power supply. Okay, then you back to the ground. Here's the ground. Okay, you go around. Can you see the circuit? Can you see through this actually? When you look at this circuit, can you actually understand what's going on? How's the current flow? Okay, then you should be able to guess this value. Okay. So clear about this? How to find the part 3?
Yeah.
You have confidence? Yeah, you read this one. This is just assumption only. Okay, this is not true. Minus 2 and this is true. It's just assumption only. Let me take away this. So you need to look at. I give you the hints. You need to look at this point, this node, and I hope I'm giving enough hints to you. Okay.
Okay.
Now we have about 15 minutes. Let's try whether we can do the last question. B123, okay. Q1C here. Let's save this. We're not going to do this today. We're not going to do this all today. We only cover half of it. Let me pick the next easier question. I think it should be this one. Should be this one. The rest are quite difficult. Okay, let's look at this question now. Mass equation. Okay, let me brief you what is a mass analysis. Okay, let me give you an example. Mass analysis tells you that you need to use the something in the loop. It's called a mass, a loop. Something like this. I1 and I2. Okay, what mass analysis saying is that you go to AI and ask, try AI, how AI answer it. One is okay, coming in. Oh, you start already. Never mind, let's try again. Oh, here, right? Mass analysis, the method to determine the current flow through the circuit in a closed loop, and it's useful to analyze it. Okay, so we must label the mass in the circuit. Usually we assign the mass current I1, I2, and then we apply the KVL. So what it means is that, for example, let me give a quick example. Let me give a quick example here. Okay, let me try to start from the easiest way to explain it, mass analysis. So you just free your mind, relax, and see how I explain it. So the mass actually has to do with the closed loop. First keyword is a closed loop. So what do we mean closed loop? It's like this. Let's say we have a power supply, 10 volt, and then this is connected to one resistor here, one resistor here, and then you also continue to connect to the next resistor. So from here, actually we can write some kind of equation already. Let's say here we have R1 and R2. Because based on the mass analysis, the first important point is that it must be a closed loop. First, let's draw the closed loop like this. From the negative, start from negative, go around and back to the initial point. This is called a closed loop. Okay, closed loop. Clear? Point number 2, it must be, you must label it I1 and I2. Okay, let's do it I1, I2. So let's label it I1. Okay, now? Next, you must use the KVL. Use KVL, Kirchhoff voltage law. Okay, use KVL means that KVL is a sum of all the voltages is equal to V1 plus V2 plus all the voltages is equal to 0. Okay, that means we have negative 10 volt because we start from here. We start from this point. Okay, we start from this point, negative. So we write negative 10 because of this negative. We start from here. We start from the left hand side. We start from the left hand side. This is the right hand side. We start from the left hand side, negative 10, and then we put a positive here, assumption. This can be assumed first. We put the positive here. So plus the voltage across R1 plus the voltage across R2 is equal to 0. This is a KVL for this circuit. Okay or not? You clear about this? If you don't clear, you let me know. See, I can explain it further. Which part you confused?
The VT equals to
V1
a
plus
bit,
V2.
yeah.
You mean you're not sure about this?
Yeah.
This equation? This one actually, it tells you that the sum of all the voltages total is equal to all the voltages in the loop, in the mass, Sum of all the voltages in the mass, it must be equal to 0. So you sum all the voltages here should be equal to 0. So this is what it means. Okay, now if you understand, then I want to try to test you by giving you one exercise. Hold on, yeah. Let me give you let me dig out the exercise. The mass analysis. Oh, here. So this is question one. Let me double confirm. This is the question 2 to C. Question 2C. All right, Miss Tan, I want you to try. If you understand what I mean just now, I want you to try find the current I1, I2 from this circuit. Okay?
Okay.
You try, I'll give you 5 minutes. You do whatever you can, okay? Even though it's incomplete, it's okay. You try, because you cannot just learn how to do it by watching. You have to you do it yourself first. You have to make some mistake, therefore you learn from your mistake. Okay, you need to try whatever you know. So you know like how far you know. You will know yourself how far you know, how much you know. Okay, you try first, huh? I'll come back later.
Okay.
All right, I'm back. Okay, Ms. Tan, so since we still have 2 more sessions before the due date, because the due date is on February 11, we still have February 4. Oh, sorry, we only have 1 session left. Sorry, 1 session left because the lab is on the February 17. So the next session when we meet, we will continue this tutorial. But right now, let me show you the answer for this circuit.
Okay.
Let me show you that. Okay, first we need to draw 2 mesh, or sometimes we call the loop, I1 and I2. Okay, we look at I3. I3 is the different method. Okay, right now we look at I1 and I2 only. I1 and I2. Okay, then we will have. Let me see. Okay, let's look at I1 and I2 only. I1 and I2. So we use the KVL. Again, we use the KVL. Here, KVL. To sum all the voltages in a mesh. So we sum the voltages here in this mesh I1 minus 20 plus 5 I1, 5 volt times the current, Ohm's law, plus the 10. The 10 actually it has 2 currents associated with the 10 ohm. So one is the positive. Why I1 is positive? Because I1 is I1 is flowing this way, but I2 is flowing the other way. I2 is going from bottom to the up. Is the bottom to the top, right? So I2 is negative. Because if you look at the 10 ohm here, if you stand here, I1 is flowing from the top to the bottom, and I2 is flowing from the bottom to the top. So I2 must be negative value. And then you move over to the next mesh. You can see the next mesh. You start from 8. You start for the 8 here, positive 8. And then you go around. I2 is positive, but I1 is negative. I2, because you going this way, I1 is going from top to down, I2 is going up. Because if you follow I2, I1 is opposite direction. So I1 must be negative value. And then you plus 2I to I2. So you have 2 equations. You have 2 equations. You have 2 unknown. Then you can use the mathematics to solve for simultaneous equation. You use the symbolic online. You can solve for, okay, you can do it by hand. Do it by hand. You solve for the unknown x and y. Okay. Then you can find the current to be 2 ampere and 1 ampere. You clear? Okay, if you want me to show you step by step, I will do it next time. Okay, but you can try first. You can try on your own to solve this question. I give you the answer already. Answer is I1 is 2 ampere, I2 is 1 ampere. Okay, for this circuit. Okay, one is 2 ampere, the other one is 1 ampere. Okay, you can try this one on your own first. When the next time when we meet, we will go through this again, and then we also look at the real question again. Because the time is already up. Okay.
Okay.
Any last question before we go? Any last question you want to ask?
No.
Before we meet next time. we're going to meet on the February 4.
Yeah.
Okay, if you have no further question, then I will see you on February 4. You're going to be from 5 to 8.
Okay.
Or from 5:30 to, we
5
stick
to
schedule. Yeah, we stick to the original schedule from 5:30 to 8.
Oh, 5:30 to 8.
Okay.
Okay.
So the next time we meet is on the 27th, is on February 4. Okay. Please pay attention because this recording is for another 2 students also. Please take note that the 27th January lab session has been moved to 17. Okay. Gina is 27 January. This is a replacement. This is a replacement. It moved to 17 February. Time is the same. Whole day is a whole day. Whole day's lab session is it. All right. If no further question, I'll see you on the next session, which is February 4. All right. Okay. Have a nice day, Mr. Okay. Bye.
Okay. Thank you. Bye.